solve example 2.1 of our NCERT Chemistry Class 12, and you can find this question in page number 38. So the question says to calculate the mole fraction of ethylene glycol which has the molecular formula C2H6O2 in a solution containing 20% of C2H6O2 by mass. So what do we have to calculate? Mole fraction, right? In order to calculate the mole fraction, we need a formula. So what is the formula of mole fraction? So now we get mole fraction is equal to number of moles of the component by total number of moles of all the component. So what is the component here? From the question we can see that ethylene glycol is the component, and solution is, you have to know that it's made up of solute plus solvent. Solute plus solvent will make up the solution. And solute means which is present in lesser quantity, and solvent means which is present in larger quantity. So what is the solute here? The solute here is ethylene glycol, and the solvent will be water. So we will now need a new formula, that is number of moles. How to calculate the number of moles? So now we have this formula, that is number of moles, that is given mass by molar mass or molecular mass. So now to solve this question, we need two formula, that is mole fraction and the number of moles. So now let's try to find out the number of moles of ethylene glycol. So moles of ethylene glycol. What is the given mass? The given mass means the given mass by the question. That is, we have 20. See, if you read the question containing 20% of ethylene glycol by mass, so you just change the 20% into mass. That is, you can just write as 20 is the given mass. And how to calculate the molar mass? What is the molecular formula of ethylene glycol? We have C2H6O2, right? So how to calculate the molar mass? We just need 2 into what is the atomic mass of carbon? That is 12, right? 6 into atomic mass of hydrogen is 1 plus 2 into atomic mass of oxygen is 16. That is 24 plus 6 plus 2, 6 are 12, 2 1 is 2, 3, that is we'll get 60, then 62. 62 just. So now we get the molar mass 62, so let's write 62 here. Okay, and let's divide it and we'll get the moles. 2 3 are 6, 2 1 is 2, 2 1 is 2, 0, that is 31 divided by 100, then 10, and then we'll put 0 because it's 2 less. Then how much do we get? If you solved it, you will get moles of ethylene glycol, you will get it 0.322 moles. So now we'll calculate the moles of what? Water, right? So now we'll calculate the moles of H2O. What is the given mass? From the question we can see that for ethylene glycol it is 20%. So out of 100, if 20% is ethylene glycol, what will be the remaining? The remaining is 80, right? 100 minus 20, 80. So the given mass of water would be 80. And what is the molecular mass of water? H2O. Just do 2 into atomic mass of hydrogen 1 plus atomic mass of oxygen 16, that is we'll get 18. So just write 18 here and divide it. If you divide it, then you will get it 4.444, you'll get this value. So 4.4444, right? Moles. So now we find out the moles, right? So now we can find out the mole fraction, and mole fraction is represented by a Greek letter called as chi. Okay, it's similar to x but not exactly x, but it's a Greek word called as chi. And so now the question wants us to calculate the mole fraction of ethylene glycol, that is C2H6O2, right? So what is the number of moles of the component? We said that the component is ethylene glycol. So what is this one? 0.322. And total number of moles of all the component. So we need to do 0.322 plus 4.444. We need to do this one. And let's find out the value. So I get this value. So let's put it in here. 0.322 by 4.766. And if you take out the point, you will get 322 by 4766. Just divide this two. And let's see how much we get. If you divide this two, then you will get something like 0.0677, which you can also write it as 0.68, right? Okay, 0.0677, so 0.068. This one will be the mole fraction of ethylene glycol. Why we don't put any unit? Mole fraction will not have any unit because it's a fraction. It's just numbers, so it will not have any unit like mole inverse, liter inverse. It will not have those. It will just be the number of it. It will just be the number itself. So now we find out the mole fraction of ethylene glycol, which is the answer. This is just the answer. And if we have to calculate the mole fraction of water, then we can just write it as that is the mole fraction of water, is equal to 1 minus 0.068. Why is this? Because the total number of moles in a solution will be always unity, that is 1. So everything, all the total number of moles of all the component will be always equal to 1, that is unity. So all the, what is in the solution, how many components are there? So we have two components, that is ethylene glycol and the water. So 1 minus the other side, then we'll get this one. So what is 0.068 will minus with 1, right? So how much do we get? 8, 9, 10, 2, 6, 7, 8, 9, 3, then 9, 0.392, right? 0.932. This is the answer. So now we get the answer, that is the mole fraction of ethylene glycol 0.068 and mole fraction of water 0.932. So this is how to find out the mole fraction. So I'm going to solve from example 2.2 of NCERT chemistry class 12, and you can find the question in page number 38. So the question says to calculate the molarity of a solution containing 5 grams of sodium hydroxide, that is NaOH, in 450 milliliter of solution. So in order to calculate this question, we first need to find out the formula of molarity, because the question wants us to calculate molarity. So for molarity formula, we have moles of solute by volume of solution in liter, and we can also represent molarity as capital M. And we say that solution is made up of two components, that is solute plus solvent, right? And solute means which is present in lesser quantity. So what is the solute here? Sodium hydroxide and NaOH, right? So what is the, how to calculate the moles of solute? Moles is equal to molar mass, given mass by molar mass, right? Given mass by molar mass. And what is the given mass here? We have 5, right? 5 by, what is the molar mass of NaOH? So let's calculate NaOH equal to sodium is, the atomic mass of sodium is 23, plus oxygen is 16, plus hydrogen is 1. So how much we get? 6, 7, 8, 9, 10, 0, 2, 3, 4, 40, right? So we get this one. 5, 8 are 40, equal to 8, 1, 0, 0.81 is 8, 2, 0, 8, 2 are 16, then we'll get 4, 5 are 40. We'll get this one. So we'll get this one. 0.125. So for the moles of solute, we get this one. So let's write it in here. That is 0.125. This is the mole. And what is the volume of solution in liter? But according to the question, we get milliliter, that is 450 milliliter. So we need to convert the milliliter to liter in order to get the molarity, right? So let's convert milliliter into liter. So 450 by 1000, isn't it? So okay, let's do 125 by let's take out the point. Okay, if we need to take out the point, then all the point 1, 2, 3, it will be downside now, and into, and then it will be reversed, that is 1000 by 450, right? And we can cancel this 2, and now we'll get 125 by 450, right? And we can also divide this 2 by 5, that is 5. 5 2 are 10, 5 5 are 25, 5 9 are 45, 0, 5 5 are 25, 5 1 is 5, 6 7 8 9, 5 8 are 40. Then we'll get 5 by 18. And let's divide 5 by 18 again. 18, okay, 18 by 5. Since it's 2 less, we'll get 0 point, and let's see how much. If you divide it, then you will get 0 0.277, and you can also write it as 0 0.278. So the molarity is this one. Okay, so now molarity of the solution will be M is 0 0.278 mole M. You need to before in mole fraction we don't put any value, right? But for molarity you need to always end with this one. Okay, you always need to end with this one. Or if you want to make it longer, then you can just write it 0 0.278 mole liter inverse. Why mole liter inverse? Because this one is, you can see from here, this one will be moles, right? And liter is downside, and if you put mole and liter inverse, okay. Or if you don't want to write it this way, only M also will be enough. So this is the answer and how to find out molarity. And let's solve example 2.3 of our NCERT chemistry, and you can find the question in page number 39. So the question says to calculate molality. So now it's molality of 2.5 gram of ethanoic acid CH3COOH and 75 gram of benzene. So remember the difference between molarity and molality. Molarity is about aqueous solution. So remember, molar aqueous solution, but molality, it will be about gram. Okay, it will be about gram, and for molarity it will be about liter. Okay, so now in order to calculate this question, we first need to have one formula, that is how to find out molality. So what is the formula of molality? So now we have this formula. Molality is equal to moles of solute by mass of solvent in kg, right? So what is the formula of moles? How to find out the number of moles? We have number of moles is equal to what? Given mass by molar mass. And what is the given mass here? We have 2.5, right? And what is the molar mass of CH3COOH? Let's find out. CH3COOH. Atomic mass of carbon is 12 plus 3 into atomic mass of hydrogen is 1 plus 12 plus atomic mass of oxygen is 16 plus 16 plus 1, right? 12 plus 3 plus 12 plus 16 plus 16 plus 1. Then how much? If you solve it, you will get, if you add it, you will get 60. So 2.5 by 60, right? And equal to, well, if we take out the point, 25 by 600, we'll get this one. And let's divide it by 5. 5 5 are 25, 5 1 is 5, 5 2 are 10, 0, then 5 2 are 10, 5 4 are 20. Then we'll get 1 by 24, right? And let's divide it again. And if you solve it, you will get it 0.04166, and the moles of solute will be 0.041. Instead of writing 66, you can just represent it 0.0417. And what is the mass of the solvent? In kg, right? But we have this one, the mass of the solvent is in gram. So we need to convert it into kg. So how to convert it? 75 by 1000. Again, this one. So do you know why why ethanoic acid is the solute and benzene is the solvent? One simple way to know is see the gram. This is present in lesser quantity. 2.5 is in lesser quantity, so this one has to be the solute, and this one is in larger quantity, so this one has to be the solvent, right? Or from the question, if we look at grammatically, it is in benzene, right? So sugar in water, salt in water, right? In the same way, ethanoic acid in benzene. So the solvent is the benzene. But most importantly, we can just know it by comparing their gram. 2.5 gram is much smaller, so this has to be the solute, and 75 gram is much bigger, so it has to be the solvent. So let's calculate this one. Do you know why I can do it this way? Because you can see 0.0417. How many after the point? How many are there? 1, 2, 3, 4. 4 are there, right? So in order to take out the point, I write 415 by 1, 2, 3, 4. 4 zeros. And then if we're going to divide this one, this has to be upside down. So this one is coming up and 75 is downside. So let's cut 3 zeros and 3 zeros. So what do we have now? We have 417 by 750. So let's divide this two again. And if you solve it, you will get 0.556. Then 0.556. And what will be the unit? For mole fraction, it doesn't have unit, and for molarity, it has the unit is m, capital M, or we write it as mole liter in bars. But for molality, how to do it? So solute moles, right? Moles. So moles, mole by kg, right? Then so we have mole by kg. So how to write it? Mole kg inverse, right? See, mole, we can also write this mole kg inverse. So 0.556. So only this much, just only this much. Well, this part are just rough calculations, and just this much is the answer. So it's very simple. Molality is, just remember the formula, moles of solute by mass of solvent in kg. And the difference between molarity and molality is that molarity is for aqueous solutions, and for molality it's in terms of kg. Okay, so this is the answer.